Hi, this is Tim. Welcome to the Math League YouTube channel. So today we've got target problem number 8 from elementary school test 12124. This was given out in December of 2020 and January of 2021. All right, so you can read through the question and you'll see that the diagram is mostly there, but there are a few pieces that we want to add, right? So rectangle ABCD, we've got side length AB with length of 72. So let's go ahead and mark that in. BC has a length of 60. Now, as soon as they give us this information, before I even move on to the next sentence, I want to observe that I have a right triangle here, triangle ABC, with two legs of 60 and 72. What I want to do is ask myself, what can we get from that, right? Anytime I have two legs of a right triangle, I can immediately get the hypotenuse. Now, it's probably good to notice that 60 and 72 can reduce down to a 5 to 6 ratio, right? 60 is 5 times 12, 72 is 6 times 12. So just imagine a smaller right triangle here with sides of 5 and 6. That'll make the calculation of the hypotenuse easier. Then we just multiply everything by 12 when we're done. So what is the hypotenuse? We'll call that x for now, and we see that x squared equals 5 squared, or 25, plus 6 squared, or 36. 25 plus 36 is going to be 61, so x is the square root of 61. Now, of course, that means that AC is 12 times the square root of 61. Now, they did mention that G is the midpoint of AC, which means that each half of this is going to be 6 times the square root of 61 over here, 6 times the square root of 61 over here as well. All right, so we're kind of looking ahead to see that G is the midpoint in order to go ahead and break that down appropriately. Okay, what else have we been told? Segment EF is perpendicular to diagonal AC. So we have a right angle here, just like we had a right angle at B in the original triangle. Now this is where things get interesting for us, right? So we have a situation here where we now have, we started with triangle ABC and we got that hypotenuse. Now we can look at triangle AGF. Now remember, a lot of times in problems like this, you're looking at triangles, you're looking to figure out, what do I know about these triangles? Can I find the sides? Can I find the angles? Are there any relationships between triangles? And in particular, I want to point out the relationship between triangle ABC, which is a right triangle, and triangle AGF, which is a right triangle. They both have this angle in common. And because of that, and the fact that they both have right angles, that means that AGF is a similar triangle to ABC. So if that's the case, that means that if AB to BC was in a 6 to 5 ratio, that means over here, we've got a 6 to 5 ratio from AG to GF. So if this is a 6 to 5 ratio, and this one is 6 root 61, then that means that GF is going to be 5 times the square root of 61. Now notice that we're just kind of playing around with the diagram at this point, and we haven't even looked at what they're asking us to do. What are they asking us to do? They want the area of quadrilateral FBCG. So we want this area. Okay. Let's take a look at what we have. In order to find the area of this quadrilateral, it's kind of a weird shape. So what I like to do is use stuff that we know. In particular, we can find the area of ABC very easily. So let's just write that over here. The area of ABC is going to equal half of that 72 times 60 that we have, or 72 times 30 would be another way that we could write that. And 72 times 30 is going to equal 2,160. We know the area of triangle AGF. That's going to equal half of 6 root 61 times 5 root 61. Now, when I multiply 6 root 61 times 5 root 61, the 6 times 5 gives me a 30. The root 61 times root 61 gives me a 61. And we do need to take half of that. So we're going to divide that by 2. What does that give us? Well, I've got 30 divided by 2 is 15, so it's 61 times 15. Let's do it this way. 60 times 15 is going to be 900. And then we've got an extra 1 times 15, so that's actually going to be 915. Now notice what we've got at this point. I have the area of triangle ABC. That whole thing is 2160. And then we found triangle AGF, the area was 915. So at this point, if we want to find the area of the quadrilateral, we take the whole triangle ABC, we get rid of the stuff we don't want, which is AGF. In other words, the area that we're looking for, the area of quadrilateral FBCG is going to be triangle ABC, 2160, minus triangle AGF, 915. 21 minus 9 is 12, 60 minus 15 is 45, and we get an overall area of 1245. And that's how it's done. Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.